Great, hiya. My name's John Byrne. I'm just going to do a little video on the ideal gas equation. This is just I think, second out of three videos, just introducing the principles and formula. If you want to see where the ideal gas equation comes from, then, well, let's have a quick look actually at the revision. It's essentially coming from looking at pressure, volume and temperature of a gas, temperature measured in Kelvin there, note that. When we combine three gas laws together, then we could discover that pressure times the volume divided by the temperature in Kelvin is a constant, and we can keep that ratio and work out what the new pressure, volume or temperature might be if we change one of those things. But we've also got a couple of other equations, so we're going to look at this one, PV equals nRT, whatever that means. Okay, so that's the basic idea. This, if you're studying this as part of a Unit 5 Level 3 Applied Science course, then you'll get given this formula in the question. All right, P is pressure, V is volume, T is temperature in Kelvin. So let's just make sure we're happy with that. If you haven't watched the other videos, just to remind you, temperature in Kelvin is equal to the temperature in degrees Celsius plus 273. 0 degrees Celsius would be 0 plus that. So 0 plus 273 is 273, so 0 degrees Celsius would be 273 Kelvin. All right, okay, so things that are a little bit new in this equation now. Well, where that comes from is the fact that there's PV over T equals a constant, and that constant is N times R. Okay, R is sometimes called the molar gas constant, the universal gas constant, or the ideal gas constant. Molar gas constant, let's write that. And some of you may know that this is about, off the top of my head, I think about 8.13, and there's a few other numbers in there. And there's some units in there as well. But that's the kind of value, and again, you'd have to get told that. So it's probably something like joules per mole per Kelvin, to be honest, are the units. Looking just off the top of my head. Okay, so that's what R equals. It's a fixed number. So every time you get the equation, you put that fixed number in there. All right. N is something new for some people, and this is number of moles. Okay, so what's a mole? So 1 mole is defined as the number well, 1 mole of carbon, let's put it like that, 1 mole of carbon is equal to 12 grams of carbon. And the reason that is because 1 mole contains 6.02 times 10 to the 23 particles. So it could be atoms, could be molecules. 23, can you see that a bit better? Lovely, and if we weigh out 12 grams of carbon, there's 6.02 times 10 to the 23 particles there. So you'll notice that the 12 corresponds to the, depends how you describe this, but the nucleon number or the relative atomic mass. Yeah, relative atomic mass of carbon is 12. All right, so 1 mole is that. And again, you'll have to be told that, or you'll be working that thing out. Okay, lovely. So it's just a scaling factor. 2 moles of carbon would be 24 grams, and that would contain twice as many particles. 2 moles would contain, would that be 12.04 times 10 to the 23 particles? Quite a lot. So if you think about, it's a scaling factor just to make the numbers a little bit more manageable. Okay, so what we're going to just have a quick look at here is how do we rearrange the equation before we substitute our numbers in. So we're going to start off with PV equals nRT. That's where we start. You'll be told that in the question. Okay, so what if we want to find out the pressure? What if you're told the volume of the gas, the number of moles, that's a constant, and you're told the temperature, obviously in Kelvin. What do we do? So we want to get P the subject. We have to get rid of V. They're just multiplied by each other. What do we do? As they're multiplied, we divide by both sides by V. It will cancel on this side. So in full, it becomes PV over V equals nRT over V. And of course, V's cancel. And therefore, we could just write nRT over V. Okay, and then we just multiply 8.31 times the number of moles times the temperature in Kelvin divided by the volume in meters cubed, and that will tell us the pressure of that gas. Okay, so that's if we're trying to make P the subject. What if we want to make volume the subject? Well, similar story. Instead of dividing both sides by V, if we want to make V the subject, well, we just divide both sides by P. It would cancel on this side, but we have to divide both sides by P, so it becomes nRT divided by P. Number of moles times the molar gas constant, 8.13, times the temperature in Kelvin divided by that pressure. Okay, all very good. Couple more to do. Let's have a look at the next one. Starting with pressure, volume times nRT. What do we do now? So imagine we want to work out the temperature. Okay, so can you see how it's N times R times T? So to get T on its own, we simply just divide by both of those fellas. Just getting the unknown quantity on the left-hand side first, perhaps. nRT equals P times V, pressure times volume. Then to get T on its own, we divide both sides by nR. So they'll cancel on the left-hand side. But if we divide this side by nR, we've got to divide this side by nR. So nR. So to work out the temperature in Kelvin, we just multiply the pressure times the volume and divide it by, probably put those in brackets, the number of moles times the molar gas constant, 8.13. All right, that's how to work out the temperature. R is a constant. You're not going to change. That's always going to be a fixed value. You're never going to need to work that out. I seriously doubt. But and if you did, just rearrange it in the similar way we've done today. But last thing is the number of moles. Imagine you told the pressure of a gas, the volume of a gas, and the temperature of a gas. Then how many moles would that contain? So what do? PV equals nRT. We want to get maybe nRT on its own on the left-hand side, because the unknown quantity n I like on the left-hand side myself. To get n on its own, we've got r times t as well. So how do we get rid of that? On this side, we divide both sides by rt. It will cancel on this side. But if we've divided the left-hand side by rt, we've got to divide the right-hand side by rt. Number of moles would be the pressure in pascals, the volume in meters cubed, the ideal gas constant, and then multiplied by the temperature in Kelvin. Okay, so a very quick look at how to rearrange the molar gas equation for the ideal gas equation, where you're told a number of moles or you're working out the number of moles. All right, thanks. Best of luck with it all.